Alright, last video on this part of Riemann sums, which is the area of common geometric figures. My last warning to you that calculus is hard enough, and that sometimes they're going to pitch us something in these classes, or a professor's going to throw us something that's going to look horrible. And we're going to start to do calculus, and what we should have done is possibly think about it geometrically. So let's look at this one for a second. This is the definite integral from 0 to 4 of x dx. Now we can integrate this and we can do all this work and we can use the fundamental theorem of calculus to solve this. But what might be easier and therefore smarter, maybe smarter, is to look at this on the Cartesian plane and say, what does this thing look like? And what it does look like is this, I believe. Right? It's this function. Shoot. Sure it is. Pretend it passed right through that. Yeah, see that? It looks like this function here. But we're only interested in it from 0 to 4. So I'm going to take a look at that. Say 0 to 4. So here's 0, and let's pretend this is 4 right here. And then if we look at this geometrically, we're really asked to find this. And again, let this 4 be that place right there. Right? And we know that the area of a triangle is equal to 1/2 base times height. Well, clearly we know that the base here is 4 minus 0 is 4, so we have 1/2 of 4 times a height. Well, what is f of 4? When x is 4, y is also 4, so 4 times 4. So we get 1/2 of 4 is 2, 2 times 4 is 8. So we spared ourselves all the calculus. If you put this on an exam, and this is your justification for your good calculus, this is great justification. I'm going to say that again. This is really good justification. You can't just look at it and go, is 8, but this is your justification. This is your explanation and justification for why what you said was true. All right, let's try another one. So the next one that I wanted to try was this one. It's very simple. It looks like hell a little bit. So your professor says to you, hey, what is the definite integral from 0 to 2 of 2x plus 5 dx? And what you do, instead of rushing into the calculus that you always do, you ask yourself, kind of, what does this thing look like? Starting with the Cartesian plane. So here's René's plane here, René Descartes' plane. And it looks, 2x plus 5 looks like this maybe. Except it doesn't make that noise. Sorry. Well, all right. And then we start looking at this point. This is the point 0, 5, isn't it? And this is that 0 we're looking for. And we want to go all the way out to x is 2. So let's call this x is 2 here. This thing would actually be a lot steeper than this, but forgive me if you don't mind. So this is 2. And now we're going to say this. Hopefully you can start seeing this geometric shape show up. So, okay, well, this is our geometric shape. Is this thing in total from here to here, from here straight up, from here, close this up. And hopefully you're seeing this as a trapezoid and you're saying to yourself, hey, I know something here, that the area of a trapezoid is equal to 1/2 height. Some people call it h halves. Either way you want to do this is fine. A plus B. You have to think about this a little bit because this is A in this case, this is B in this case, and the height is this one. So we know all of these numbers. Now it's just fill in the blanks. No calculus required here. So it's a great way to get an answer quick without having to do a lot of work. So we have 1/2. 2 minus 0 is our height, so 2. Then we have A. A is a height of 5. Just filling in the blanks. This plus sign is this plus sign. And what is this height? Well, when x is 2, we have 2 times 2 plus 5. Well, 2 times 2 is 4 plus 5 is 9, isn't it? So we would get here 1/2 times 2 is 1. 1 times 5 plus 9. 5 plus 9 is 14. So we have our definite integral happens to be generated from the area of a common geometric figure, and that is actually equal to 14. All right? Look, you guys, I can't overemphasize to you, this stuff gets really, really rugged. So when they're throwing you out really easy ones, let's not slip up on those. Let's make sure we get those and put them in the bag, right? Nobody knows where you got your points. They all go in the same place, don't they? Okay, I hope this was really helpful. If you haven't already subscribed, please subscribe. And your comments, of course, are always welcome.